All right, hello everyone. So we're gonna, the purpose of this video is just gonna be to talk about using our regression model for prediction as well as to introduce residuals. And so if you remember when we did that kind of initial model with no predictors, we kind of had two goals. One was prediction, the other was kind of inference about the mean. This is going to be a similar type of deal where first we're going to talk about prediction, then we're going to talk about kind of inference about whether we can determine if our two variables of interest are associated. And so for prediction, we first just need to write the equation of our fitted regression line. And so last time we had said that the fitted intercept was 3.79 and the fitted slope was 0.09. And so what I'm going to predict for my response, or my predicted course score, is going to be that fitted intercept plus whatever that fitted slope is times our predictor. So this is just an equation of a line. Before, you might have seen, like in an earlier math class, I forget when this pops up in math, but probably a while ago, you probably wrote an equation of a line as like y equals mx plus b. This is the same deal, except we're gonna call the intercept beta naught, and it's gonna, or b0, and it's gonna come first. And we're going to call the slope b1, and it's going to come second. And so just by convention in statistics, this is almost always how you'd see the equation written, so we're kind of ditching that type of convention. Okay, so then using our regression equation, let's just predict what the course evaluation score would be for a professor with an attractiveness rating of 5. So remember when we had that constant model before, our predictions were just all the same because we didn't have any predictors in the model. Now our predictions are going to be different depending on what the professor's attractiveness rating is. And so for 5, it's just as simple as plugging 5 into attractiveness and then just solving this. And so if you do this calculation, you end up with the course score of 4.24. So that's it for prediction. It's really not too bad. You usually just write out the equation and then throw in for x whatever you're kind of interested in predicting. Excuse me. For residuals, we're just defining, we had a definition for these before, as just leftover variation in the data after accounting for model fit. And so just keep in mind that we can't predict course scores perfectly from attractiveness. And because we can't predict course scores perfectly just based on someone's attractiveness, there's leftover variability. So that's all that that's saying. The residual, how we're actually going to calculate it, is that we're going to take the observed response and subtract what's predicted based on our model. And so this is going to be our observed response. This is going to be our response predicted from our model. So this is really the same definition of residual that we had before. Each observation is still going to get its own residual. So if there's like 200 things in your data set, then there's going to be 200 different residuals. And so let's go ahead and practice this and find the residual for the professor with the course score of 2.8 and an attractiveness rating of 3. And so we'll eventually get around to circling it and drawing a line, but let's start with the prediction. And so their attractiveness rating was 3, so I'm just going to plug in 3 for attractiveness to get their predicted course score based on our model. Then for their residual, I'm just going to take their observed course score of 2.8 and subtract what our model predicted, 4.06. And so we wind up with the residual for this professor, for this professor's course of negative 1.26. If you're more of a visual person, we could find where this professor is on our graph. And so they had an attractiveness of 3, and they had a course score of 2.8. So it looks like they're this point right here. What the residual is then is just the distance from that point up to the line. So our residual is telling us that that distance is 1.26. The residual is negative because the professor's actual course score is less than what the model predicts. We could do the same kind of thing for a different professor. So let's suppose someone has an attractiveness rating of 5.5. So X is 5.5. A course rating of 4.9. So Y is 4.9. I'm going to first grab their predicted course score based on our model by plugging in 5.5 to our regression equation. And then I'm just going to calculate their residual as their observed course score minus what was predicted from our model. And so in this case, this professor's residual is 0.615 points. We could find them on our scatter plot, and so let's see, their attractiveness was 5.5, their course score was 4.9, so it looks like they're about here. And so the residual is just the distance from that point down to that line. And so in this case, the distance between the point to the line vertically is just 0.615. Positive now because their observed course score is higher than what the model predicted. So we've kind of said a couple things aloud while talking about these residuals, and so let's go ahead and write a couple of those things down. And so a positive residual just means that the observed response is higher than what the model predicted it to be. A negative residual, as you might guess, is the observed response is lower than what the model predicted it to be. So just to kind of drive that home, because I know a lot of us are visual, all these points that fall below the line that I'm circling right now, all of those are going to have negative residuals. All of these points that fall above the line that I'm circling, all of those are going to have positive residuals. Okay, and so that's about it for prediction. In the next video, we'll get more into, okay, well, we've had this line from the get-go, but what makes it kind of best? And so we'll talk about that next.